Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to calculate Gibbs free energy changes and to predict whether or not a reaction is spontaneous or not from the delta H and delta S. Okay, so let's get into this. So here we have an equation, we have a reaction where we have the decomposition of carbon tetrachloride gas into solid graphite, solid carbon in the graphite form plus chlorine gas. And so they're giving us, oops, sorry about that. So they're giving us the delta H and the delta S. They're both positive. So we're going to use the equation, the following equation for delta G. So the delta G we're going to calculate is equal to delta H minus delta S multiplied by temperature. And again, the temperature is in Kelvin. Now, how do we know if something's spontaneous or not? It's going to be based on whether or not we get a negative delta G or a positive delta G. If we get a negative delta G, it's spontaneous. If we get a positive delta G, not spontaneous. So let's plug in our values. Now, so we need to calculate the temperature in Kelvin. We're giving us 25 degrees Celsius. So the temperature is equal to 25 degrees Celsius plus, we're going to add 273 to that to turn it into Kelvin. And so that's going to give us 298 Kelvin. So we got our temperature. Now the thing is, we got to make sure that our delta G is in the right units. For delta G, the units are going to be in joules. We're going to calculate joules. And so with regard to the delta G, we should make sure everything's in joules. Now here we have kilojoules and here we have joules. So we're going to convert this into joules. So for that, we're going to have to multiply by 1,000, right? So we use our conversion factor. I'll write it up here. So we have 95.7 kilojoules. We're going to put that over 1. We're going to multiply that by our conversion factor, 1 kilojoule over 1,000 joules. Kilojoules cancels out. And now we have 9, that's going to be 9.57 times 10 to the 4 joules of energy. Let me double check that. Okay. Yep. So now we're going to take our delta H that we just calculated, or we just converted to joules, and now we're going to plug everything into our equation. So we're going to write it down here. So delta G is equal to delta H, which we just got here. So that's going to be 9.57 times 10 to the 4th. Okay. And we're going to subtract that from, and then the delta S. So here's our delta S. So we're going to subtract, and that's going to be a positive 142.2 joules per Kelvin. And that's going to be multiplied by our temperature in Kelvin, which we have 298 Kelvin. So the Kelvin cancels out. Oops, I forgot joules. We can't forget our units. So I have joules here, joules here. So when we calculate this out, we end up with a delta G of, here, let me calculate it off a little bit more. So we have delta G is equal to 9.57 times 10 to the 4th joules. And that's going to give us a minus, what do we get here? 4.24 times 10 to the 4 joules. And then when we subtract that out, we get, let's see, or sorry, yeah. So when we subtract that, we're going to end up with 5 point, what I get, 33 times 10 to the fourth joules. Make sure I got that right. Yeah. So here we have our Gibbs free energy. So you'll notice that that's a positive number. So for spontaneous reactions, we want them to be negative. We want delta G to be negative, but we got a delta G that's positive. So this is not spontaneous. So not spontaneous. Okay, so going on to B, if the reaction is not spontaneous at 25 degrees, determine what temperature, if any, is this reaction spontaneous? When does it become spontaneous? And so in order to answer that question, if we look at our equation here, we look at delta S is positive, and we know that this is subtracting this positive from here. So if we could, excuse me, if we increase the temperature, then we're increasing the negative part. And so if we can increase the temperature enough, maybe this part here would overcome the delta H, which is positive. So we need to find the temperature at which this delta G becomes negative. So it's going to go from positive, right? So it's going to go from positive and it's going to increase the negative so that we're going to get to 0. And as soon as we get to 0 and start moving into the negative delta G's, that's when we become spontaneous. So we need to figure out when 0 happens. What temperature does 0 happen? And so what we do is we just set delta G to 0, right? Delta G is 0. And then we're going to set that equal to our delta H. So delta H is equal to, minus delta S times T. So we need to figure out at what temperature the Gibbs free energy change, the change in Gibbs free energy reaches 0. So we plug in our values and solve for the temperature. So again, we want everything in terms of joules. So again, this is 0 joules here. And so we're going to plug in the value. So we have 0 joules is equal to delta H. We calculated the delta H over here. So we're going to put 9.57 times 10 to the 4 joules minus the delta S. Again, delta S is here. So minus a positive 142.2 joules per Kelvin, and then T for temperature. So now all we need to do is solve for temperature. And so here we got 0 here. So we're going to bring this to the other side. So we're going to subtract both sides, 9.57 times 10 to the 4 joules. And we're going to subtract 9.57 times 10 to the 4 joules on this side. So now we have negative. So we're going to have negative 9.57 times 10 to the 4 joules. And then now that's going to be equal to this side, which is negative, because a negative and a positive is negative. So 142.2 joules per Kelvin times T. So now all we need to do to find the temperature is divide this by both sides. Divide both sides by negative 142.2 joules per Kelvin. So go ahead and do that. So negative 142.2 joules per Kelvin. So divide it there. And then we're going to divide negative 142.2 joules per Kelvin there. And so now this cancels out. This cancels out. We have T for temperature on this side. And now we just divide this together. The negative and negative are going to cancel out. And so when we divide that, we get, what did I get? Temperature is equal to 673 Kelvin. Double check that, 673. So this is the temperature at which the reaction that we have here, the decomposition of carbon tetrachloride, becomes spontaneous. So we would need to raise the temperature to 673 Kelvin, and at that point, it will start to become, or above that temperature, it would start to become spontaneous. So we calculated that this is the temperature at which delta G is 0. So it's still not spontaneous at 0. So if we get a higher temperature, if we go above this temperature, then the reaction becomes spontaneous. So I hope this was helpful. If this was helpful in any way, if you enjoyed this video, then please like the video, share it with your friends, hit that like button over there. Also, make sure you subscribe to my channel, hit that notification bell so you can be notified by all the videos I put out. Make sure you click all for all the videos. And then also make sure you put a comment down below. I would like to hear from you. If you have any questions, I would love to answer them. Any suggestions, I would like to hear them. Thank you for joining me. Have a great day.